In this video, we're going to talk about how to name aldehydes. So let's start with the basics. An aldehyde is basically a carbonyl group where you have a hydrogen on one side of the molecule. So this would be an aldehyde. To distinguish it from a ketone, the ketone has no hydrogens attached to the carbonyl group. So this is the ketone. So let's say if we have a 4-carbon aldehyde. How can we name this particular aldehyde? Now, 4 carbons is associated with butane, but instead of calling it butane, this is going to be butanol with an Al. So anytime you see an Al, that is the suffix for an aldehyde. So what about this one? What is the name of this particular aldehyde? If we count the carbons, we can see that we have a total of 7 carbons, which is associated with the name heptane, but we're going to add the suffix Al, so it's going to be called heptanol. Now what about this one? How can we name this particular aldehyde? So let's count the longest chain. There's 5 carbons, so it's associated with pentane. But we do have a methyl group on carbon 4. So this is going to be called 4-methyl and pentanol. As you can see, the aldehyde is always at carbon 1 when it has the highest priority. So you don't have to say 1-pentanol. You simply just say pentanol. What about this one? Feel free to pause the video and name this particular example. So we have an alkene on carbon 3, and we have a 6-carbon aldehyde. So this is going to be called 3-hexene, since the alkene is on carbon 3, and then 3-hexanol. Try this one. So we have an amine, an ether, an alcohol, and an aldehyde. Which group has the highest priority? It turns out the aldehyde. Groups that are always at the end, like aldehydes, esters, carboxylic acids, they typically have the most or the highest priority compared to the groups that can exist in the middle, generally speaking. Now we need to put it in alphabetical order. So the amino group is going to come first, and then we have the hydroxy group, and then the methoxy group. So it's 6-amino dash 3-hydroxy dash 4-methoxy, and I'm running out of space, and then after that is simply octanol, since we have an 8-carbon chain with an aldehyde. Let's try another example. So which group has the highest priority? The ether, the aldehyde, or the ketone? Well, we know it's not going to be the ether. And between the aldehyde and the ketone is always at the end. So the aldehyde has more priority than the ketone. So this is going to be number 1. Now, this group, instead of being methoxy, we have an ethyl attached to an O, so this is going to be ethoxy. And here we have a ketone as a substituent. It's called oxo. So E comes before O, so we're going to call it 3-ethoxy dash 4-oxo, and then hexanol, since we have a 6-carbon chain. And that's all you got to do for that example. So now what about this example? This time we have a carboxylic acid and an aldehyde. Both groups exist at the end. Which one has higher priority? The carboxylic acid has more priority than the aldehyde, so it's going to have a number of 1. So then this group is now the substituent, so it's going to be called oxo. But B comes before O, so let's start with bromo. This is called 4-bromo dash 6-oxo, and then hexanoic acid, since we have a carboxylic acid. So what about these two? How can we name this particular compound? So the aldehyde is going to have the highest priority. And let's identify the longest chain. So we have a 6-carbon aldehyde, so that's hexanol. But what about these substituents? What are they called? Well, on the left we have a 6-carbon ring, particularly a benzene ring, and as a substituent it's called phenol. On the right, notice that we have a benzene ring plus this extra carbon, so we have 7 carbon atoms instead of 6 carbon atoms. And because of that extra carbon, it's known as benzyl. So let's put it together. B comes before P, so this is going to be 2-benzyl dash 4-phenyl dash, and we have a total of 6 carbons, so hexanol. Let's take out the dash though. You only need a dash between a number and a letter. So this is it. 2-benzyl dash 4-phenyl hexanol. Here is another example which is very common on exams. So make sure you know this one. So how can we name this molecule? We have a cyclohexane ring and an aldehyde. So together it's called cyclohexane carbaldehyde. And that's something you just have to commit to memory. So make sure you know that one. So if that's cyclohexane carbaldehyde, what happens if we add a methyl group to it? If you do that, this is going to be carbon 1, that's carbon 2. So now it's called, let me try to fit it here, 2-methyl, and then cyclohexane carbaldehyde. So now that you understand that topic, you know the answer to this question. What is the name of this particular molecule? Go ahead and try it. So this is going to be 1, 2, and 3. We don't want to count in the other direction because if we do, it's going to give us a higher number. You want to count it in such a way that you get the lower number for the substituents. So this is going to be called 3-hydroxy cyclopentane, since we have a 5-carbon ring, and then after that, the word carbaldehyde. Now what about this one? It looks like cyclohexane carbaldehyde, but we have a benzene ring instead. So a benzene ring plus an aldehyde functional group combined, this is called benzaldehyde. Now what if we decide to add, let's say, a CH3 and a chlorine atom to it? So now what is the name? So this is going to be carbon 1, 2, 3, 4. We want to count in that direction. If we do, we get a 3 and a 4. If we count it in the other direction, the two groups will be at 4 and 5, which is higher than 3 and 4, so we don't want to do that. So C comes before M, so this is going to be called 4-chloro-3-methyl, and then benzaldehyde.